Now, factor number 2, pH. So what I want to tell you is that each enzyme has a specific pH range. For example, pepsin, salivary amylase, trypsin has its own optimum pH. So for example, pepsin works in acidic pH condition. So amylase works in slightly acidic and trypsin works in alkaline. Function optimally. Function optimally in alkaline condition, which is optimum pH for trypsin. So you can see all enzymes react most effectively at their own optimal pH. How about if I slightly change the pH? For example, if I put trypsin into neutral, condition, the pH changes will change the charge of the active site of the enzyme and the substrate surface. Yes, so this will change the charge of the substrate of the enzyme. And this will prevent the enzyme substrate complex from forming. So when you don't have this enzyme substrate complex, you don't get the product. So what I want to tell you is that every enzyme has its own optimum pH. So if I slightly changes the pH, the charges of the active site of the enzymes and also the substrate will be changed. This will prevent the enzyme substrate complex from forming. But if I return it to the optimum pH, will restore the charge and normal function. So if you restore the charge, so the function will back to normal again, and then you can get the products. But what happened if I put the trypsin from the alkaline back into the acidic, which is extreme pH changes. You see, extreme pH changes. Extreme pH changes, and this extreme pH changes will cause the chemical bonds to break. And we say that denature. Denature means that the chemical bonds in the enzyme is broken. When it's broken, the 3D shape cannot be. The 3D shape is loose. So we say that the active site, when the 3D shape is loose, the active site will be changes, and then no longer complement. The substrate no longer complement the active site of the enzyme, so that no more products are formed. You can get me? So what I want to tell you is that pH, every enzyme has its own optimum pH. If I slightly change the pH, never mind. This will prevent the enzyme substrate complex to form. But once I restore the pH value, it will go back to function normally. But what if I extreme pH changes? Extreme pH change will break the chemical bonds. The active site will be changed. No more enzyme substrate complex are formed. No products are formed. You get me? So the third factor is a substrate concentration. So just now I say that if you want the enzyme substrate complex to form, you need the coalition. You need coalition to form the enzyme substrate complex. So low concentration means few coalitions. But if you have high concentration, means that the chance to get the effective coalition is more higher. When more higher, more enzyme substrate complex form, more products are formed. So that in the third factor is the substrate concentration. In the fourth factor is the enzyme concentration. You manipulate the concentration. So you can see if I increase the substrate concentration, will increase the effective coalition, and more more what? More enzyme substrate complex are formed, more product are formed. And what if maximum level? Maximum level means that the rate of reaction remains constant. Why? Because all enzyme active sites are saturated, are already being fitted by substrate. Even though the substrate concentration is very high, but the enzyme is the limiting factor. The concentration of enzyme is limiting factor. Means that there's no more enzymes to fit to add on the substrate. Although you have many substrate, right? You have many of the substrate, but there's limited number of enzyme. So you need enzyme and substrate to bind together. But because there's limited number of enzyme, so of course the rate of reaction remains constant after you have reaching the limiting factor. So the rate can only increase. The rate can only increase if you add more enzymes. So now we see enzyme concentration. Also the same. You have many enzymes, so enzymes will provide more active site to add on the substrate. More active site to add on substrate. Okay, and then you see why it become like constant, because if today you have many of the enzyme, you have many enzymes, but you have limited number of substrate. So even though you have many enzymes, but you don't have enough substrate to fit into the enzyme to form what? Enzyme substrate complex to form the product. So you see the rate of reaction after reaching the maximum level, it becomes constant. So how are you going to increase the rate? How are you going to increase the rate? By adding more substrate. So we see so substrate concentration will increase the effective coalition. Also the same, enzyme concentration will provide more active site so that more effective coalition can occur. But what is the limiting factor? Limiting factor for enzyme concentration is substrate. You have many enzymes, but you don't have enough substrate to form the enzyme substrate complex. Same goes to the substrate concentration. And then the pH, every enzyme has its own optimum pH. If you slightly change, I cannot form the enzyme substrate complex. If you extremely change of pH, denature, enzyme denature. And temperature, very easy. Kinetic energy increases, frequency of effective coalition increases, and then the rate of reaction is maximum at the 37 degrees Celsius. That's all for the factor. That's all. Thank you.